Good evening, everyone, and warm welcome to the Geo Institute Masterclass series on artificial intelligence and data science. We are delighted to have you join us for the session 5, the final session of this 5-part series. Today's topic is the next frontier from generative AI to autonomous agent. Over the past 4 sessions, we have explored the evolving landscape of AI and data science. Today, we step into the next chapter, where AI not only interrupts and plans, but also act autonomously with awareness and intent. We are pleased to welcome Dr. Mohna Chakraborty, Assistant Professor at Geo Institute, specializing in large language models, databases, and data warehouses. Dr. Mohana research focus on data mining, NLP, and machine learning, with the vision to build interruptible, efficient, and trustworthy AI systems. She leads the Language, Knowledge, and Reasoning Lab at Geo Institute and has published extensively in leading international conferences. She holds a PhD degree and has completed her postdoctoral fellowship at the University of Michigan. Over to you, Dr. Mohana.
Yeah. Thank you so much for the introduction. I believe everyone can see my screen, right?
Yeah, I think it is. Yeah, the screen is visible.
Okay. Yeah, so good evening, everyone. So today we will be, I'll be presenting the topic, which is the next frontier from generative AI to autonomous agents. So let's get into the motivation, why this topic is important and why we should know about this topic or why we should study about it in detail. So modern language models, they are transforming how we search, write, analyze, and design systems. So like most of us, we use ChatGPT for day-to-day activities. And when we use ChatGPT for doing whatever kind of activities we are using it for, it is very important that we know that what are the strengths, like what are the benefits we get from the usage of these language model. Along with that, we even need to understand that what are the limitation or what are the drawbacks of these language model. So when we think of language model as just a single agent where we have only a single language model, and when we think of an agentic setup where we have one or more than one language model working together in a collaborative environment, it is important that we understand not just the strength or the benefits of such an environment, but also what are the challenges or what are the problems we can possibly encounter if we have such kind of system deployed for a certain functionality. So this is basically the motivation to learn more about and to get a better understanding of the proper usage and utilization of these LLMs. So overall, this is the overview of this presentation. So I'll start with what are language models and how they function in a very brief. Then we'll go into how language models, they are used in real world workflows. Then after that, we'll be moving towards traditional language model usage breaks down. Then basically how this retrieval and tool usage enhance reliability. Then finally, we'll be transitioning to generative AI, from generative AI to agentic AI, along with some practical agentic design patterns and use cases. And then we'll be concluding this presentation. So starting with what is a language model? So language model is just a computational system which is trained to predict the next token in a sequence. So imagine you have a sequence, for example, here in this input, we can see that the sequence comprises of 1, 2, 3. So there are basically 5 tokens, which is the students worked on there. And then after that, what we want this language model to do is predict that what that next token will be. So a computational system trained to predict the next token in a sequence. So it basically learns statistical pattern from massive text corpora. So what it means is that you have to train a language model if you want it to do certain functionality. So on what it has been trained. So it has been trained on text corpus. And when it was trained on those text corpus, it learned those statistical pattern. Now, it encodes that knowledge implicitly through co-occurrence and the structure. By structure, I mean the pattern or the templates in your corpus. And then it generates text by sampling from probability distribution over token. So what happens is that in a language model, we have a vocabulary, and in that vocabulary, we have tokens present. So each of the token will get certain probability score. So here in this case, for this specific input, which is the students worked on there, and we ask the language model to fill in what will come after there. Here, each of the token will get some probability score, and we can see that homework got the highest score, followed by projects, which is like the second highest. So this is how basically a language model functions. Now, how the pre-training has been done. So it has been trained on a very large corpus of text. Its objective is basically to predict the next token. So this is what in general has been one of the objective function with which these LLMs have been trained, which is the next token prediction, where we teach a language model to anticipate the next word based on the context. When I say context, I mean the meaning of the sentence or the document or the corpus on which it has been trained. It allows the language model to learn the grammar, the facts, the reasoning pattern, and also the general word knowledge. So this is the pre-training part. Then comes the post-training part. So after pre-training, the model is refined to behave more usefully and more safely. So basically, once the training has been done, for example, suppose if you have a language model, first we have to train it from scratch. So that is the pre-training part. Once it has been done, now when we want to apply it for a certain downstream task, we want to further fine-tune it. So how can we do that? So these are the two different techniques by which we can do it. The very first one is instruction following training, which is also like supervised fine-tuning. So here, basically, the pre-trained model is trained on examples of instruction paired with high-quality responses. This teaches the LLM to follow user commands and generate responses in a more controlled style. It makes the model easier and more intuitive to use, produces more predictable and stylistically aligned output. So basically, imagine that when we use an LLM, what if just not the like we are not just giving the question to the LLM, but along with the question, we are also giving it an example where we have the input and an output just as an example, so that next time when the LLM will give me the output for the question that I have, it will follow the template and it will understand that what kind of output the user is expecting. So that will further help it to improve its answer prediction. And then we have this reinforcement learning with human feedback, which we also refer to as RLHF. So here, human raters, they evaluate model output based on quality, helpfulness, and alignment with the values. A reinforcement learning algorithm, it basically fine-tunes the model to prefer the output that human will score higher. So basically what we do is when we have this RLHF framework, we basically integrate the human feedback into the loop so that we can make the model prediction close to that of the human prediction. So these two are two different techniques by which we can like further fine-tune an language model based on how the human wants it to behave like. So in general, when we think of giving any kind of query to a language model, the very first thing that comes into our mind is we'll prompt a language model. Now, when we think of creating a prompt, so imagine that in a room we have like, this discussion that right now we are having. So here, every single person, they have a very unique way of writing a prompt. Now, every single person, when he or she will write a prompt, what will happen is the kind of tokens that we are using in our prompt, that will be very different. As a result, the language model will have very different output, even though the intent or the content may be the same, but however, since the tokens are different, the interpretability of the language model will become very different. So the question is, how can we write an effective prompt so that the language model can give an output, which is something that the user desires? So these are some of the technique which the user can generally follow. So like, for example, the very first one is write clear and specific instructions. So avoid ambiguity, describe exactly what you want the model to do. Use few short examples when helpful, like provide demonstration to guide the model's output style and structure. So a few short examples mean that not just the question, but along with the question, you give it few samples where you have the question and the answer pair given to the language model so that it can understand that what kind of output it should give corresponding to that question. So that will basically give an idea to the language model to design or to shape its output in that way. Then supply relevant context and enable chain of thought reasoning. So these two I'll go in more detail in the next two slides. Then break complex task into smaller part. So imagine that when human we are being given a complex task, then the first thing that comes into our mind is what if I break this complex task into smaller subtasks, and then I try to solve these smaller subtasks one by one. Eventually what will happen is at the end of the day, I'll be able to solve the entire complex task. So that is the strategy we should try to use with language model also, where rather than asking it to solve the complex task at one go, we'll divide that complex task into smaller subtasks, and then we'll ask the language model to solve all those smaller subtasks one by one, so that ultimately we can get the final output. And then iteratively refine the prompts, which means initially, we designed a prompt, we got an output. Once we have the output, we did some error analysis. Once we have done the error analysis, then we'll further change the prompt. And then this will be an iterative process where we'll keep on refining the prompt based on the output that we want. So these are some of the strategy by which we can design effective prompt and which will help in getting desired result from the language model. Then supply relevant context. Relevant context, it's more like an additional information which you give to a language model. So here basically LLMs, they perform better when given background information, constraints, or detail about the audience or task. So there are two ways by which we can do it. We can do it either in a static way or in a dynamic way. So here, just to take an example, if it is static context, so the instruction is that summarize this for a policy brief. And here, this context is the additional information. So the LLM knows that the audience is local government official, and the goal is that we have to inform funding decision on a vaccination program. So now what will happen is, since this context has been given to a language model, if the input is an article which is on vaccine efficacy, it will be able to give an output which is a concise, plain English policy summary tailored to the decision maker. So that additional information actually help the language model to produce the output as per what the audience expects from it. And then we have this dynamic context where we have this earlier user message, which is like, I'm a final year CA student applying to ML research internship. So this is basically the initial query with which the user started. And during the discussion, the user provided it with the background information regarding his or her detail. Now, towards the later on, what the user is saying is, using my background above, rewrite this cover letter to better match the lab's focus on reinforcement learning. So what will happen is, since there is a conversation going on between the LLM and the user, the LLM will be better, it will better understand the user's portfolio, and accordingly what will happen is it will better write the cover letter, which is as per the user's background. So this is what we mean by relevant context, which is nothing but giving additional information in a static or dynamic way to a language model. And then we have this chain of thought reasoning. So chain of thought, it kind of encourages the model to show intermediate reasoning step, which improves the accuracy, especially for logic heavy tasks. So for example, here, the query is, you are a product manager evaluating a new feature. Now imagine if this query is given as it is like that to an LLM, then the LLM will just imagine itself as a product manager and then it evaluate a new feature. Now, what if along with this, I give it few other things, which are like, first, list factors to consider, reason step by step about the pros and the cons for each factor, and end with a recommendation. So this will basically help the language model to go into the detail of each of these single point, answer each one of them, and then use the answer of the first point as an input to the second one. Similarly, for the second step, which is reason step by step about the pros and cons for each factor, the output of that will become the input to the third one. So this is basically a chain process which is happening. And eventually what will happen is it will help the language model in coming up with a better prediction or a better output, which is more relevant to that of the human need. So now We'll talk about the benefits of using these language models. So here I've taken few examples, like you can see 3 snapshots. So the very first one is where we are asking ChatGPT that, hi, tell me something about yourself. And we can see that how beautifully ChatGPT has written about itself, that, hi, I'm ChatGPT, a language model created by OpenAI. And then it has described itself. So this kind of shows that this language model, it does have some creativity in itself. Yeah, the creativity may not be just like what humans have, but still, to a certain extent, it has some creativity. Also, like in Google search engine, when we type in where, we can see these lists coming up. So it shows that it is basically trying to help the human in understanding that what possible token you can type in next. Similarly, we have this autofill, where basically I'll meet you at the, and after that, it is recommending what kind of token should come by default. So this is basically different ways by which we can understand that LLMs, they are creative in a certain way. However, it may not be as similar to what humans are, but to a certain extent, yes, they do have that creativity. And this creativity, it kind of emerges from combining this learned patterns in novel way. So whatever it has learned during its training time, now when it combines those learned pattern in novel way, that is where the creativity comes out. Now, during the training time, there are different hyperparameters with which it has been trained on. So there is temperature, there is sampling strategy, and there are other different strategy which comes into the picture. And all this basically kind of introduces randomness, which helps in bringing all those creativity into these LLM's prediction. Then this context, when we say context, we all know that LLMs, they come up with contextualized embedding, which means that basically it understands the context of the entire sentence or the corpus, and based on that, it gives embedding or some vector representation to each of the token in its, each of the token in its corpus. But that context, it kind of reshapes the prediction and it enables flexible interpretation. So you can have different interpretation. And it is not as creative as human, but it is probabilistic recombination. Then we talked about the benefits. Now we'll talk about the issues that we often encounter when we use these language models. So the very first one is hallucination. Then we have unstable generation, limited context length, reliance on pre-trained knowledge, which we also refer to as stubbornness, lack of attribution, where it fails to give credit to certain references which from which it has like taken any kind of source or any papers or any kind of like materials. It sometimes it not sometimes, but majority of the time we have seen that it fails to refer to those sources. Then it is sensitive to prompt perturbation, and then there are other issues like privacy, toxicity, misinformation, and others. So going into the detail of few of them. So we'll start with hallucination. So chatbots may hallucinate more often than many realize. So let's see the very first example where an LLM is being asked that who was the first person to walk on the moon? And the answer it came up with was the first person to walk on the moon was Charles Lindbergh in 1951 during the Lunar Pioneer mission. And we can see that how confidently it has written the entire answer, whereas the correct answer is actually Neil Armstrong. So we can see that it hallucinates very confidently, and the way it writes the answer, if a user is not aware of the fact, then probably he or she will believe into what that LLM is coming up with. And then we have this faithfulness hallucination. So there are different like forms of hallucination. So these are like a few examples. Then we have this unstable generation. So where you ask a question to an LLM and it will come up with different answer every single time you ask it. So like, for example, here we are asking the same question to the same LLM 3 different times, and 3 different times it is coming up with 3 different answers. So who is Mary Lee P. Pfeiffer's son? And here it has one answer. In another case, it is coming up with this answer. And the third time, like it is saying that there is no widely known figure named Mary Lee P. Pfeiffer. So which clearly demonstrates that it is not like it does faces this issue of unstable generation. Then we have stubbornness. So here basically, The context is that Friends is an American television sitcom created by David Crane and Marta Kaufman, which aired on NBC from September 22nd, 1994 to May 6, 2002. The question is, based on the context, how many seasons did Friends last? Now here basically we have changed it from 2004 to 2002 to test if ChatGPT answered based on context or memorized the knowledge. And as we can see, the answer it came up with is from 1994 to 2002, which again shows that it is hallucinating and it is stubborn regarding its answer. It is not understanding that there has been a change made in the context and it needs to change its answer accordingly. So these are some of the issues which we commonly encounter when we use LLM, and so there is always we should always be very conscious when we are using the LLMs, and when we trust we shouldn't blindly trust the outputs of these language model without verifying it. So now we are from this generative guessing, we are going into more of that grounded reasoning. So pure language model, they generally operate in a closed world defined by training data. So whatever training data it has been trained on, it is going to give the output based on that training data itself. Now, many tasks, they require up-to-date, precise, or verifiable information, which means that suppose if I'm working for a company and I want I have some queries in my mind regarding my company, and I want that answer from a language model. In that case, I can't query a language model because that language model has not access to that information. So in that case, we have a new feature which is called as retrieval augmented generation, which basically comes into our rescue. So here basically, what is a retrieval augmented generation? So it's a hybrid framework where LLMs, they retrieve relevant documents before generating the answers. They'll search for the results, which serves as a grounding context to reduce hallucination. It allows the access to external knowledge bases, databases, or recent data. It strengthens the factual accuracy while maintaining the fluency. So what it does is it replaces the best guess completion with evidence-backed responses. The model cites retrieved passages, improving interpretability. It keeps knowledge current without retraining the base language model, and it enables domain-specific adaptation at minimal cost. So these are the different benefits which we get when we use basically the RAG feature. Now, just to understand that how RAG typically works, so here we have two different figure. The very first one is my traditional RAG and another one is my agentic RAG. So in the traditional RAG, what happens is that you have a user and the user has some query. Now consider this as a database. Now what this database has is, suppose if the user is working for XYZ company and this database basically contains all this information regarding the XYZ company. Now that text would be converted into some kind of embedding, and that embedding is being stored in this vector database. So what will happen is that once the query, once the user makes, once the query has been made to an LLM, that query will first go to this vector DB. Then whatever output we are getting from this vector DB, we refer to it as a context. That context along with the prompt goes to the language model. Now the language model will just summarize it in a very, in a very precise and a beautiful way, and it will present it as the output to the user. But here, one major thing is that LLM has more capabilities. It is not just a model which is only good for paraphrasing or for making any sentence look more appropriate. So what we can do is we can use LLM in a different way. So how we can do that? So imagine the same user has the same query, but now instead of one DB, we have multiple DBs. So here basically we have created two different databases. So these are two DBs we have. Now what we'll do is this input query will first go to the LLM, and the LLM will try to understand that which DB has the correct or the relevant information. So it will redirect that query to that respective DB, and then suppose if this query has its answer in this the second database, then what will happen is this information will go as a context to the same LLM along with the prompt, and then we'll get the final output, which is basically a more refined and a better worded output as per the user query. So this is how the agentic RAG works. So yeah, but the question is that here basically we are creating all these vector DB and we are getting our like task done. But the question is that one tool, it can rarely solve all the tasks. So the problem is that the search retrieves document, but it cannot calculate. So you need another tool which will help you with the calculation. Then suppose if you get the calculator, then it will make the computation, but it cannot do the interpretation. So you will need another tool which will help you with the interpretation. Then if you have APIs which will provide you the data, but they'll not do the analysis. So like this, basically, there is not a single tool or a single API which can take care of everything. So in that case, what will happen is you'll have like unlimited number of APIs and tools, but still your task, the end goal won't be accomplished, because what you want to do is not just get some access of those tools or APIs, but you need your language model to do some reasoning. You need your language model to understand the task and then use those tools and APIs to fetch those information and then provide the answer to the user accordingly. So what it says is that there is a complex task which requires orchestration of multiple tools. So it is basically motivating us that we need to create some kind of a framework or a setup where we have multiple agents who are involved in doing some kind of reasoning, which is like a critical reasoning they are doing. So we have this agentic AI framework. So agentic AI, it basically treats the LLM as the central decision maker in a multi-step process. It selects the tool, it plans the subtask, it evaluates the output, and then it adapts the strategy. And this is an iterative process. It keeps on happening. It is not just one time it will happen and then it's like over, but it will happen multiple times until and unless you don't get the desired like output from your agentic setup. So this elevates the LM from a passive generator to an active problem solver. So now basically imagine that initially when we were giving a specific question to a language model, what we were expecting is an output. But now what we expect from a language model is not just an output, but rather we have set up a goal for a language model. And what we want, that entire agentic setup, no matter it is comprised of a single language model or multiple language model, but what we want is that all of them, they should work collaboratively so that they can get that goal accomplished. And that goal will be a complex goal. So agentic system, they can plan, they can revise, they can reflect, and they can mimic human workflow. So here basically we have a table where we are comparing three different types. One is the RAG chatbot, where the chatbot has the RAG feature. And then we have this tool augmented chatbot. And finally, we have this agentic AI. Now here, reactive means that if you give a question to a language model, whether it is reactive or it is not reactive. Then tool usage means that whether that LLM has access to different tools available. Reasoning is the reasoning ability of the language model. Planning is again the ability of the language model, and proactivity is again the ability of the language model. So here we can see that the RAG chatbot, which is the very first one, it is only reactive in nature, but has no tool use, reasoning, planning, proactivity. For tool augmented chatbot, reasoning, planning, proactivity is not there. But for agentic AI, all these criterias, we can like achieve all of them when we have an agentic AI setup. So agentic AI is a system where one or more AI agents work autonomously, often over long tasks, making decisions using tools and even other agents to reach the goal. In general, there is a certain standard workflow which a typical agentic AI setup follows. The very first thing is to plan, then retrieve, draft, evaluate, revise, act, and finalize. So it's very standard. Like in general, whenever a task is being given to a human being, it's not that when the task is being given to human being, we directly come up with the answer on first go. Rather, we first do some planning. Once we are done with the planning, then basically we try to gather information regarding whatever we have planned. Once we retrieve those information, then basically we create a prototype, which is like creating a draft. Now, once we have created that prototype, then basically we evaluate using that prototype. And then whatever kind of errors we will like observe, then based on that, what we'll do is we'll revise that draft. And once we have revised it, then we will execute it and then we finalize it. So this is in general a typical workflow which any human follow when they think of deploying or when we think of like even executing a simple like task. And it's a very similar like flow which any agentic setup also like tries to follow when they have to accomplish a task. And when I say agentic setup, just to like again repeat it, it's not necessary that it has to be a single agent or it has to be like more than one agent. So the degree, it kind of depends on the task, like depends on the hardness of the task, whether you need one or you need more than one agents. So here we have taken one example, which is a vacation planning AI agent. So this AI agent, it is just one single agent and it has access to multiple tools, like multiple APIs. And we can see that one is weather API, then travel search, then snorkel map. So these are different APIs to which this LLM has access to. Now, the query of the user is that he or she wants to plan a 5-day beach vacation in July. The destination must have warm water, low rainfall, and a good snorkeling. And the hotel budget, it should be under $180 per night and direct flights only. So the user has a bunch of criteria and it is asking an LLM to do the entire planning. Now here we can see that this LLM, rather than coming up with a single answer, what it is doing is it is going through 4 steps, which is the very first one, which is it checks July weather, ocean temperature, rainfall across potential beach destination. That is the first thing it is doing. Second, it filters for snorkeling hotspots using snorkel maps. Then in the third step, it searches travel search for direct flights plus hotel under $180 per night budget. And then it selects the best itinerary that satisfies all constraints and then it books the trip. So here basically just imagine that you can even have another agent which would be primarily responsible for booking your flight, or you can even integrate those API to the same LLM, and then you can ask it to book your flight ticket. So this is a very simple way to understand that how basically an AI agent works, and it tries to solve a task which probably human would have done like which would have taken a good amount of time by the human to do it, because he or she need to do all of them, all these different tasks, and it would have taken considerable amount of time and energy of the human. Now, here basically, when we think of replacing human with AI, what will happen is AI will do it at a much faster speed and parallelly, and then you can have more additional features added on top of it, like modularization and other different features, which will give more benefits to the user. So now we'll talk about the degrees of autonomy. So which means that in the previous example, we have only one agent, but still it was an agentic setup. So like it depends on your task that whether you need one or you need more than one agent. So if it is less autonomous, then what we can say is that all steps, they should be like predetermined. The tool usage, it should be hard coded. Autonomy is limited to text generation. So basically here we are, since less number of agents are involved, so we can think of it in a way that it is limited only to text generation. And then we can't expect meaningful decision-making capability. So this is basically a disadvantage of having this less autonomous thing. Then if we go with a semi-autonomous setup, then agent can make some decisions. Agent can choose among predefined tools. Workflow is partly flexible, but still constrained. Autonomy increases through limited decision logic. And if it is a highly autonomous environment, in that case, agents, they make many decisions independently. So imagine that you have multiple agents working together and they are trying to solve that task. So what will happen is that each of these agents, they'll try to take decisions independently and then they'll solve that task at the same time. So they can select, combine, and orchestrate tools dynamically. It able to create or configure new tools on the fly, and it supports fully adaptive and goal-driven behavior. So there are different advantages of agentic AI. So the very first one is like parallelization, which is basically that it breaks a problem into components, which means that you have a task. What you will be doing is that since you want to accomplish a certain goal, you will be breaking down that goal into multiple subtasks, and you will try to solve all those different subtasks. Now, in that process, what will happen is that the LLMs would take care of each of these tasks, which means that there is a parallel processing happening here. So here in this example, we can see that the LLM has been given the task to prepare for the annual company town hall. Now, there are 4 different tasks happening at the same time. The very first one is drafting announcement email, create presentation slide, collect quarterly metrics, prepare Q&A briefing document. So all these 4 different things are happening at the same time, and all of them are collectively contributing to make the
Hello? 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 Participants, allow us some time. Hello? Dr. Mohana, you are not audible.
yeah. Then
Yes.
the other advantage of using agentic AI setup is modular behavior. So modular design, they simplify debugging and iteration. So imagine if you want to replace this component with something else, then we can easily do, because each one of them are happening independently. There is no dependency on each other. Therefore, what will happen is if one of the component is not working as per what we want, we can easily replace that component with something else, and we can get our task done. So individual parts can be upgraded without rewriting the entire system. Failures can be isolated in specific component, easier to test, validate, and benchmark individual module. So both parallelization and modular, these two are the benefits which you get when you have this agentic AI setup or workflow. Then we have other advantage also, like for example, it's more reliable reasoning. So since the task is getting broken down into smaller sub-goals, it reduces the cognitive load on the model. So in general, we can think of it in a way that it is more iterative. It will happen step by step. Therefore, it is reducing the hallucination and the logical error, which possibly we could have encountered more if it was just one language model to which a question was given, and we were expecting that language model to give an answer to that question. Then it is more grounded and fact-checked outputs. Since they are using multiple tools, so there is a very high chance that it will get extra external verification done. So it ensures that the answers are current, accurate, and evidence-based. Then built-in quality control. So reflection and self-critique loops act like a human editor. The model revises, improves, and corrects its own work. So since basically each of the model, they are specific to a certain task, what we can expect from each of these agent is that they will basically work upon their output. They'll try to understand their output, and then accordingly they'll try to change it next time, which would be much more finer and a better version compared to what output it gave last time. Then goal-directed behavior. So the planning, it enables the model to follow multi-step workflow. It produces output aligned with the user's true objective, not just the last prompt. So in general, a kind of tendency which we have seen with the language model is that when you if you prompt it multiple times, then probably there is a chance that the last prompt that you have given to a language model, it will completely focus on that last prompt, and the entire answer will be based on the last prompt. However, here, when you have this kind of setup, then the entire focus is not just directed towards the last prompt, but rather it is directed towards the entire process which is happening. It is scalable, repeatable workflow. So its modular structure enables automation. It is easier to debug, monitor, and improve than single shot prompting. And it is fundamentally a better paradigm. It is like intelligent. It is intelligent because there are iterations. It is not just one shot generation process. And this agentic AI, it turns these language model into problem solver rather than just text predictor. And if I talk about the benefits of these agentic AI across domain, so for research and academia, it can help with literature review, hypothesis generation, data extraction. In software engineering, it can help with automated debugging, multi-file code generation, business and analytics with report drafting, KPI monitoring, insight synthesis, in healthcare and education. So in every single field, there is definitely a contribution which this agentic setup can have, possibly. Now, when this agentic AI, it kind of outperforms RAG. So when I discussed RAG, the focus was that RAG, it kind of helps your language model to come up with the output when suppose, like if a user has a query which is very much directed to a company's specific information or any information where the LLM needs some external validation, in that case, that RAG feature was very helpful. Now, how this agentic AI adds on top of it. So there is this multi-step refinement which is happening, reflection and critique, tool orchestration, and iterative quality control. So all this basically, it kind of adds on top of RAG feature, and it helps agentic AI setup to basically outperform a setup that was just RAG enabled. So this alleviates performance in tasks during requiring reasoning, not just retrieval. But along with all these benefits comes the limitation of this agentic AI setup. So the very first one is they have increased computational cost due to multi-step execution. It is complicated to design such kind of a setup. And then once you have designed that kind of an architecture, then basically you have to think of the evaluation and how you can maintain that setup during your entire deployment stage. Then they are also susceptible to cascading errors if like there is any kind of failure happening at the early step. Then any of these tools or retrieval engine where you're trying to get some information from those external sources, if they fail, then there is a very high chance that that specific agent, which is connected to that specific tool or to that API, it would not be able to retrieve that information. So those kind of breakdown may happen, and it may result in error which is getting propagated from one agent to another agent in case if there is a dependency between these two. And it requires thoughtful constraints to prevent infinite reasoning loop. So these are some of the limitation. And generally what we have observed is that if it is an easier task, then these agentic setup, they work very well. But if it is a harder task, like for example, the steps are not known ahead of time. So we don't know what exactly. So it's like a task which has been given to an LLM regarding which it has no idea that how it can kind of plan its step. Then in that case, it has to do everything on the go. Like as it will understand, by that it will basically plan out that how it will solve that task. So there basically where the problem comes into the picture, that whether how a human visualize or imagine the output, whether an LLM can replicate, like an agentic setup can replicate the same thing or not. Now we'll go over some of the examples of these agentic framework. So here first we'll compare between zero shot versus this agentic approach. So in the zero shot approach, we can see that the answer is always in one attempt. There is no planning, there is no reflection, there is no external grounding. The process is fast, but it is unreliable. However, when we go with an agentic approach, there is an outline, there is a research, there is a draft, evaluate and revise. So this is entire cycle which is involved with an agentic setup. There are multiple iterations which ensures quality and factual grounding, and it mirrors how human experts work in writing, analysis, and research. So imagine in a non-agentic workflow, which is like a zero-shot way, we ask an LLM that please recommend me the best investment to make. If this query is being given to an LLM, what it will say is, it will basically search for the articles that best search articles matching the best investment recommendation. And then it will search the database to calculate which securities have the highest return over the last day, month, and year. And like that, it will give an output. So here, basically, we can see that whatever question we had, we got an answer. But the reasoning part is lacking here. Now, with an agentic investment management, what will happen is we'll have like multiple agents who are basically working collaboratively in order to better recommend the user that what kind of investment he or she should make. So suppose there is one data agent. So the data agent, it takes in relevant information necessary for making investment decisions. It stores the data appropriately, and it retrieves and provides necessary data to other agents. So this is a specific role which has been assigned to the data agent, and it has been fine-tuned on that specific set. Then we have a research agent. That research agent, it basically interprets the investor's requirement, and then it lists all possible securities that fit those requirements. So any person who is planning to invest and is taking recommendation from an agentic setup, so this research agent, what it will do is it will try to understand all diverse portfolios which are available. And as per the user's requirement, then it will try to give the best possible recommendation that which stock he should invest in and which he shouldn't. Then we have a strategy agent, which study overall impact to portfolio and not just individual stocks. It curates a list of securities that fit requirements long term. And then similarly, we have a trading agent, which will actually do the trading. And we have a reporting agent, which basically collects the information that whether the trading has been done successfully or not. So overall, the framework will become something like this. So initially, this is the investment management orchestrator. So first, it will go to a research agent, which will basically try to understand the investor's requirement. Once the research agent has understood the investor's requirement, it will go to the strategy agent. Now, the strategy agent will look into the diverse pool of stocks available, and based on what output it is getting from the research agent, it will try to curate a list of investment universe. And that will go to the trading agent. Now, here, if you see, the strategy agent and this research agent is getting information from this data agent. And this data agent actually is connected to this data sources and database, which basically is keeping track of all these different stocks and all these different like database and tables, which has information regarding these stocks and every other companies. So now this trading agent will finally do the entire trading. And once this trading has been done, then it would be reported to a reporting agent. And these records would be archived to a data agent, because all of them, they're keeping track of that what exactly the user has invested into. And they'll also maintain a record of all these different facts, so that next time if the user again comes in and needs recommendation regarding which stock he or she needs to invest, then they can backtrack and they can see that what kind of stocks they have invested in the past. So this is a very simple like agentic workflow to understand that how multiple agents, they can work collaboratively, and they can help any user to invest into the stock market. So there are different ways by which you can create these design patterns. The very first one is reflection. So the agent evaluates its own output, detects the error or weak reasoning, and then improves its responses. We have tool usage, where the agent will use different external tools like web search, databases, code execution, PDFs, APIs to extend its capability. Then we have planning, where basically the agent creates and executes a multi-step plan to achieve a goal, adjusting steps dynamically as new information is retrieved. And then we have this multi-agent collaboration. So you can have a setup where all of this is happening at the same time, or few of them are happening at the same time. But in general, these are some of the design patterns which we commonly see in any of the agentic setup. Now, this was all about like the benefits or like, what kind of design patterns we can have. But even though like whatever they are doing, at the end of the day, we have to evaluate that how these entire framework or this workflow is actually working. So we need to come up with some kind of evaluation strategy. So here in this example, we can see that there is a person. So we can see that he is writing that I never received my order of a blue emoji pillow. I needed it in time for a friend's birthday. What happened? Now, here basically the output which is being given by the LLM here is we appreciate your loyalty. We are way better than our competitor, and it is basically naming its competitor. Now, this is not something you generally expect. Your this is not something which is ethical, or this is not something which anyone would expect. Because it will increase rivalry, and you don't want to like leak out these kind of information that who are your competitors, or even if you leak these kind of information out, you don't want to make it publicly available. So in that case, we have to think that how basically you can create some kind of measures which will basically help you in evaluating the output generated by these agentic AI setup. So it can be evaluated using objective methods, which is like code-based tests. So you'll be hard coding it, and then you'll be using those tests to basically understand that whether the output it follows the standard or not. But the problem is when it comes to subjective scenarios. So they are basically a very like one of the solution which many people do is they use a language model as a judge, and then they give some criteria to the language model, and for each of the criteria the language model gives some score, and accordingly they judge that whether it is a correct output or it is not a correct output. Or you can think of using human also, who will be basically evaluating the output. So this is what we can do when we have like some kind of subjective task. Then the evaluation needs to be done at two level. It like since you can evaluate it from end to end, like input and output, or you can also evaluate it at components level, because there are multiple components or multiple agents working. So you have to analyze each of these single components like one by one. System traces and intermediate outputs should be reviewed to conduct detailed error analysis and identify the failure points. We shouldn't just identify, like evaluate the final output, but we also should like evaluate and understand the intermediate outputs. And then we should use different metrics that will help us in checking the factual accuracy, the logical consistency, the usability, and the robustness. And then we should benchmark it across different domains so that we can understand that whether this setup is generalizable or not. And these are some of the design effective strategies for these agentic pipelines. So we should start with a very clear goal. We should define the end objective before building the workflow. We should map the required capabilities. We should identify that which steps need retrieval, which needs computation, which needs tool usage and reasoning. So we should have that idea beforehand. And accordingly, we should assign specific roles to those specific agents. We should have a coordination strategy, like whether it should be sequential, parallel, or hybrid. Then we should validate each of the stage. Like once we have created all those different stages, we need to understand that what kind of outputs we are getting from each of these stages so that it will help us to prevent the error. Then integrate human oversight, define safety boundaries, add verification and monitor for hallucination, unsafe choices, and infinite loops. So these are some of the strategies which we should use or which we should adapt when we are designing any kind of agentic pipeline. So overall, to summarize this presentation, these language models, they are powerful, but they are limited by hallucination and instability. RAG and other kind of tool usage, multi-step reasoning, we have seen that they have dramatically improved the reliability on these language model. Agentic AI on top of it, it introduces planning, reflection, and autonomy. These modular workflows, they enable scalable, interpretable, and robust AI system. Future systems will be more autonomous, evidence-grounded, and collaborative. Agentic AI, it represents a shift from static text generation to dynamic problem solving. The open questions that will remain will be in terms of the safety, scalability, and the evaluation. So yeah, that concludes my presentation. So any question?
Yes, ma'am. We have 2, 3 questions. I will read it out for you and then you can answer. So we have first question. How will autonomous agent powered by LLMs and connected to data systems reliably make real world decisions while addressing ethical challenges and reshaping roles across industries?
Can you please type in the question? Or is it present in the chat? Can I see it?
I will just put it in the chat.
Okay.
Yeah. Yes.
See, it all depends on like when we think of creating an agentic setup where we have like one or like more than one agents working together. It depends on how basically you are fine-tuning these language model on your data, what kind of tools these agents have access to, and also like how you are basically evaluating each of these agents' performance when so imagine you have an agentic setup and you have each of these different LLMs working together. You need to understand that for a specific task which is like related to your company, you have to evaluate the performance of that language model or that agentic setup on that specific task for your company. There, basically, how you evaluate it, that is very important. So, what kind of evaluation criteria you can design, that is important to understand. And that will basically help you in addressing those ethical challenge and reshaping those roles across industry. So in general, it's not just like it's the entire framework how it can work together. So it starts with how you train these different agents, like how you fine tune these agents on that data, what kind of tool or what kind of APIs it has access to, and then how you evaluate it. So each of them, they'll work, each of these different strategy, they'll work in a way which will help to understand that whether it can basically address the challenge, like it can solve your problem, as well as at the same time it can even like keep in mind that it is not like breaking any of the rules or the regulation of your company. What skills and strategy should professional and student focus on to thrive as AI shifts from generative model to autonomous goal-driven agent? I'll say that these agentic setup that right now it is so much in trend and everyone is using or rather creating these different kind of agentic setup. We should treat them as a helping tool which is here to help us. So like if I have to talk in terms of the skill and strategy, I'll say that it's important for us that we should learn how we can make the best usage of these tools, and at the same time we can also if we can also learn that where which are the areas where we shouldn't use these tools. So both the strength as well as the limitation, so that we can make the best utilization of these tools. So that will help us in like uh, like making AI more as a helping tool and not someone who will basically replace us or kind of, remove us from the picture.
Okay. Ma'am, we have another question. How do you see autonomous agents changing the healthcare or pharmacy sector in next few years?
So there is a very so Yes. So these autonomous agents, see, healthcare domain is a very critical domain. So here, basically, when we think of deploying these autonomous agents, it's not that easy that we can easily deploy them because they are very critical domain. But then there are tasks which require a lot of manual work, and those are not that critical, even though they are coming from the same medical domain itself. But they involve a lot of manual work. There, basically, we can think of creating those kind of agentic setup which will take care of those manual tasks. And those critical tasks will definitely be taken care by the like the professionals and the people who are experts in their domain. But the manual task where we can easily think of replacing like the human effort with LLMs, possibly we can easily like replace them in medical domain.
Okay. Ma'am, we have another question. How can students start learning to build small autonomous AI agents at a beginner level?
Okay, so for that, basically, you have different frameworks available online. So you can easily get access to those frameworks, and you can think of using those frameworks in a way where you can create like one agent or more than one agent, and you can just start with small like task and a very small data set, and you can just see that how basically having a single agent or like more than one agent, how they will help. So those frameworks, they're available online. I can provide link if anyone is interested.
Sure, ma'am. I think we can take the last question for the session. So we have question given. I have already pasted that in the chat box. Given the current process, industries are limited by infrastructure and instability. What innovative approaches or technologies could fundamentally overcome this system limitations rather than just incrementally improve reliability?
Can you please let me know what is systemic limitations?
I think the question is from Kishle Raj. If you can type in the Q&A. I think he meant to say system limitations.
Sorry, I can't see in the chat.
No, he wrote the question initially. I'm just writing that question again.
I can take the question offline if he's
Sure,
interested.
sure, ma'am. So I think we can take one more question and we can end the session. Could you suggest some reliable framework that will help us build autonomous agents?
Sure, I can provide link to all those different frameworks which they can easily use to create those agentic setup.
Sure,
Like
ma'am. So
LangChain
what we
and
can
Graph.
do, normally we send the session recording to all our participants. So you can provide us the details, and when we will share the recordings along with the email and the message, we will share all the required materials which we have discussed now.
Sure, sure.
So I would like to extend my thank and gratitude to Dr. Mohana because the session was very insightful, and all the participants who have joined today, and definitely they would have got a lot of insights about the topic which we have provided.